Hello and welcome to our Ask the Expert session, Adventure to the Stars, hosted by the STEM faculty here at the Open University as part of our World Space Week 2021. My name is Dr. Alice Dunford and I'm a science communicator based in the School of Physical Sciences here at the Open University. And today I'll be chairing this session with three of our academics, where we'll be journeying to the stars with the scientists involved with the Open University Telescope facility in Tenerife. We'll be hearing about how these scientists use telescopes for research to image the night sky, learning about stars, galaxies, and a host of solar system objects. And we'll hear about how you can get involved with this science from your own home. We have a week of fascinating free events for anyone with an inquiring mind about space, astronomy, and a desire to learn about the world-leading research that we do right here in Milton Keynes. We will share more information about the rest of these talks. Today we'll be talking with three of our academics who have worked with telescopes as part of their research. Shortly, I'll be putting your questions to the experts here with me today, and I'm going to let them introduce themselves in a minute. They are each going to give a short introduction about themselves before we start the Q&A part of this session. And now, you have joined us on Zoom webinar. For everyone's internet safety, your cameras and microphones are off, but you can still interact with us via the polls. And if you look at the bottom of your screen via the Q&A button at the bottom, just in the middle, that's where you're going to be able to ask your questions to the Zoom panelists directly. Now, only we can see these questions, so feel free to ask as many as you want, and if you made a mistake, don't worry about sending another question through. Sadly, if you're watching this on YouTube, you are watching a recording, so you cannot interact with this session, but we ask you to get in touch and find out as much as you can through the links we're going to provide later during the session. This session is being recorded live and will be available on our YouTube channel after the event, so please check our social media accounts for the video, and a lot more information will be available then. Now, in a second, I will hand over to our academics, Alan Taylor, Joanna Jarvis, and Sam Jacks. Let's start with a quick poll. You should see a question appear on this screen in any moment now. And it's going to ask you, have you ever used a telescope before? Please answer either yes or no, and hopefully we'll get some more feedback as we're going through, and you'll get more involved in how you can get involved in using these telescopes. But I'm going to now pass over to Joe and Alan, who then give a brief introduction of what they've been up to.
Alice, thank you very much. Thanks for that introduction. And welcome everybody. Thank you for joining. It's good to see so many of you online for this first of our Space Week sessions. So thank you very much for the poll. I can see there's lots of you have answered on the poll there. Quite a few of you have used a telescope before, some of you haven't. And what we're going to talk to you about is a way that you can get involved and use some of our professional telescopes based out in Tenerife. So I'm Alan Kalis, and I'm a physicist and astronomer. I work here at the Open University, and I present our mainstream second level experimental module, Remote Experiments in Physics and Space, which involves using the telescopes. And I'm also co-author with Joe of our OpenLearn free online module that you can get involved with, Astronomy with an Online Telescope. So Joe, I'll just welcome you and let you say hello to everyone, and then we'll tell you a bit about the course.
Lovely, thank you, Alan. Good morning, everybody. My name is Dr. Joe Jarvis. I am a visiting researcher at the Open University and also a school teacher. As Alan has said, we co-authored the Astronomy with an Online Telescope course, and through my many years of involvement with the Open University, I've also been involved in quite a few other modules as well. So I'm really looking forward to introducing everyone to this course and to the possibilities that it opens up for you, both personally and also maybe if some of you are associated with schools, how it can facilitate your teaching.
Right, brilliant. Thank you, Joe. So let's tell you a little bit about the course that Joe and I have put together. So we've both been fortunate enough through our roles as astronomers with the Open University to work with these amazing facilities, the amazing telescopes that we have out in Tenerife. And Joe was responsible for putting the telescope facility together in the first place when it was originally based in Mallorca, and then the telescopes have been moved out to Tenerife. And because we've been so fortunate to have these amazing instruments available to us, we wanted to make those available to as many people as possible. And so between us, we've written this course, Astronomy with an Online Telescope, which is one of our free OpenLearn courses on the Open University's OpenLearn website, which you can sign up for, which will give you the opportunity to work with and to use these telescopes for yourself. And the link to that is on screen, and we've also put that in the chat so that you'll be able to go and sign up for this. So this course, Astronomy with an Online Telescope, gives you the opportunity. Some of you, I think more than half of you had said in the polls that you've used a telescope before, perhaps a small one that you've got in your own garden. But this gives you the opportunity to use these professional facilities that we're going to tell you about in this session. The two telescopes that we have out there are COAST and Pirate. And in Astronomy with the Online Telescope, you'll be working with COAST, which is the smaller of the two telescopes, although it's still significantly larger than anything you've perhaps got in your own back garden. So this is a professional grade telescope with astronomical imaging sensor on the back that can take amazing pictures of the night sky and see far more than you might see from your own back garden. And this is a 420 millimeter mirror, a reflecting telescope. So this is exactly the same design as used in all the sort of great big observatories that you might have seen, or even the Hubble Space Telescope uses a similar idea of mirrors to form an image with imaging sensors on the back rather than an eyepiece that you look at. And the great thing with these telescopes is that they're controllable from a distance. They're controllable remotely. Now, some of us, Joe and Sam and myself, have been fortunate enough when travel was possible that, you know, from time to time, we've been out to Tenerife to work with the telescopes and set everything up. But these can all be operated. You can use these remotely through the internet by signing up for the Astronomy with an Online Telescope course. And the telescopes are incredibly powerful, and the kinds of images that you'll get back in the first half of the course are these kind of things, these amazing deep sky objects. On the left-hand side here, we've got the Andromeda galaxy. This is one of our neighboring spiral galaxies. These images were taken just recently with the COAST telescope. And on the course, you'd be able to take very, very similar images. And then on the right-hand side, we've got the Dumbbell Nebula, which is a star which has cast off, towards the end of its lifetime, cast off this cloud of glowing gas here, which forms these amazing, spectacular images. So a little bit later, we'll tell you more about some of the scientific measurements that you'll be able to make as part of this course. But for now, we'll hand over and we'll pass you back to Sam to talk about some of the research work that he does with the COAST and Pirate telescopes. So.
That's brilliant. Thank you, Alan and Joe. That was amazing. I'm always incredibly jealous of anyone who's actually gone to visit the telescopes. So I'm always insanely envious of that travel that everyone's got to do. So I think I'm going to hand over to Sam. But before I do, we should have another poll appear on your screen. And that's going to ask you, looking at those images that you've seen, what of these objects would you like to see in the night sky now? So I think hopefully that should now be appearing on your screen. So have a look through some of those different objects and see what you'd like to image while I hand over to Sam to introduce himself.
Thank you very much. So my name is Samuel Jackson. My full name is Samuel L. Jackson, and I'm not the actor, I promise you. And I'm a third-year PhD student here at the Open University studying asteroids with these wonderful observatories that Alan just introduced you to. So a bit of background on me. So I just recently, before this, did my master's degree at the University of Kent and moved here to Milton Keynes to the Open University campus to do my PhD. We study the properties of asteroids, so what they're made of, how they rotate, and also the positions of them, so we can understand even whether they may pose a potential threat to Earth. It's very important questions we need to answer about a lot of these objects. and also research into telescopes themselves. So we want to know what we can do with these small scale research telescopes and how far we can push them. And that lets us understand how people with telescopes in their backyard, for example, can contribute to these scientific endeavours. And also, as part of my responsibilities, I also develop capabilities for the observatories and help to maintain them on a day-to-day basis. So when we observe asteroids, as you observe a star, it moves across the night sky as the Earth rotates. But with asteroids as well, they move not only across the night sky as the Earth rotates, but relative to the stars that you see in the night sky as well. So, as an example, we can see asteroids moving across the sky like this by taking lots of photos of many different of the same part of the sky, and we look for moving objects across the sky. So this is an example of an asteroid that's named after the Open University, and we'll probably come back to that slightly later on how asteroids can be named and things like that. But from these we can see how the brightness of asteroids change and start to infer some details about them. So as they rotate, their brightness that we see from Earth changes, and by seeing this periodic change in brightness, we can tell how fast it's rotating, and also we can tell a little bit about how elongated the asteroid is, and that starts to give us information on the shape. And as well, we can observe asteroids kind of like the phases of the moon. So you can imagine as the moon goes from a new moon, where it's not illuminated, all the way to a full moon, where it's illuminated face on, the brightness of the moon changes. And we can do this with asteroids as well. And how this brightness changes tells us about boulders and craters on the surfaces, and as well as what it might be made of. So that's what we do with the Open Science Observatories in asteroid research. And now I'll pass you back to Alice.
That's brilliant. Thank you so much, Sam. I think we're starting to get some questions in, but if you've got any questions about anything so far, please drop them in the Q&A box at the bottom of the screen and we'll ask them directly. I think our first question that we've got coming through is, we've got all these amazing telescopes. What kind of camera or iPhone app or phone app could you use to just photograph the night sky and moon? Is that possible to use a normal camera or a normal phone to create those photographs? Either Joe or Alan, do you want to do answering that?
Sure. Thanks, Alice, and thanks for that question. It's a great question. I would say probably the best way to get kind of amazing pictures of the night sky, like the ones that we looked at, like these pictures of the galaxies, absolutely the best way to get these kind of deep sky pictures is going to be to sign up to use these big professional telescopes which have the astronomical imaging cameras on them. But there's loads and loads of things that you can do with your own camera, or even with your own mobile phone camera that you might have. And there's a couple of things that you can do. The first one is actually something that Sam showed, those amazing time lapses of the night sky going past. So if you have a digital camera, so a DSLR camera or a modern mirrorless camera, just stick it on a tripod, open the lens up as wide as you can, find a nice dark spot somewhere it's safe to go, and just do a long exposure, 15, 20 seconds, and you'll be amazed at how many stars and so on that you can see with that. So that's a way to do it. Many cameras these days have a time-lapse facility, so you can set it to take a sequence of images and stitch them together. So that's a great thing to do where you don't actually need a telescope, and it's all about using the equipment you've already got. If you do have a small telescope, then if you can stick it on a solid tripod, aim it at the moon, and then you can simply hold your mobile phone camera up to the eyepiece, just where your eye would be, and you get a nice picture of the moon that way.
What do you think about binoculars as well? Do you think those are a valid option, or is it better with a telescope?
To be honest, if you've got it's about using the equipment that you've got. If you have a pair of binoculars, you might use it for bird spotting or what have you. The point about those is that the lens of the binoculars will collect more light than, you know, the pupil in your eye. And so that will allow you to see fainter objects. And it's a great way just to scan your way around the night sky. So yes, it's a really, really good way to get started.
Brilliant. Thank you so
Amazing
much.
what you can do with smartphones these days. Certainly, as Alan said, just holding them up to the eyepiece of a telescope or binoculars, and you can get a really quite impressive image. There are various apps and things out there that will allow you to make full use of your camera in your mobile phone by changing the settings beyond those that are standard for the device. And also, you know, don't forget there's, you know, those beautiful views, sunsets and so forth, you know, that you can easily image utilizing time-lapse and hyperlapse facilities and all those. So there's lots and lots of different ways of interpreting astronomical imaging.
And I'd say a good way to perhaps get into it with your phone as well is a lot of them will have what's called a pro mode on the default camera as well. And if you just get a small tripod online, if you buy it either online or if you can find one in a shop, then you can just put your phone on a tripod, and just the stability from that lets you get some really nice images just with the default camera apps on your phone as well, depending on so your sky conditions at home as well, that is.
I suppose that actually leads into a really good question next, and I think we'll talk about it more as we go through. But you've mentioned that the telescope that you're using is based in Tenerife. Is there a good explanation of why it's based there? And could you also go into some detail about what affects when we take a good photo? Do we have when we have to consider about the weather, the timing of where we're looking? I don't know if Alan or Joe, you want to start off, and then Sam, if you want to jump in.
So perhaps if I start with this one, because as Alan mentioned, the Pirate telescope, the professional version, the research version of COAST, was originally prototyped by myself and the rest of the team originally on Mallorca. And the reason that we started there was because we had the opportunity of a nice remote site, thus avoiding the issues of light pollution. And also being in a tropical environment, often you've got a much higher proportion of nights that are cloud-free. So that was, you know, an easily accessible site for doing that prototyping. But once the telescope was to the standard at which we wanted, obviously we moved it over to Tenerife, and COAST was born as well. And the reason for that move was obviously wanting to remain with a site that had limited light pollution. Again, stick with the tropical site, avoiding as many clouds as possible. We've added to that by moving to altitude, so that, you know, all the clouds that we do get, the vast majority are actually below us most of the time. And also by being at altitude, we've actually reduced the amount of atmosphere that the telescope is looking through. I mean, if you look up on a nice dark night, have a look at the stars, you'll often see, particularly down towards the horizon, that the stars are twinkling. Now, that does look quite pretty, I'll grant you that, but that's not what astronomers want. Because what is going on there is actually by looking through a thick layer of Earth's atmosphere, that atmosphere is moving, acting a bit like a lens in itself, and therefore causing the star to shift around in position from our perspective. Obviously, it's not really, and also often change colour slightly as well. So by being on the top of Mount Teide, we've reduced the amount of atmosphere that we're looking through, and thus reduced that twinkling effect as much as we possibly can.
And it's a nice place to visit sometimes when we can go and visit. Yeah.
We have to take one for the team occasionally.
Incidental benefits.
Benefits, definitely.
Yeah.
And yeah, I suppose I'd add, you do get some additional complications as well sometimes from going to sites like this. So, for example, in Tenerife, we have to deal with Saharan dust blowing off of the coast of West Africa. you get these big dust storms, which are called kalima. And sometimes we have to keep the domes closed because otherwise the dust can settle on your mirror, and it starts to degrade the quality of everything, and you can get little scratches as well. And as we've seen recently, we're located very close to La Palma, where the volcano is currently still erupting and has been for, I think, going on 2 weeks now. So you have to get this sort of altitude, usually you have to put your telescope right near a volcano, and it can introduce complications sometimes.
When you do have those complications, I imagine it's then quite hard to actually get people to the location to actually fix the problem in the first place. So it's not always, you can't do all the fixing remotely. Some of it does have to be done in person. I think, Sam, you've got a very exciting picture. I don't know if you've got it on you can share. Recently, they did an upgrade to the telescope, where you can see the issues of trying to upgrade a telescope on the top of a mountain, which I don't know if you can share that.
Yeah, I can share that just now. So here we go. So yeah, for one, you need to be able to get a crane 2,400 meters above sea level, which isn't easy as it is. And yeah, so you need to do that. You can see Mount Teide in the background, and you can actually see somewhat the effect of the sort of dusty atmosphere, is that the mountain isn't actually entirely clear in the picture in the background. It's partially atmosphere, but also a bit of dust in the atmosphere, and you can see how that might affect your images when you look at the night sky as well. And yeah, this is the example of trying to attach it as well. You have to try and crane it in and grab at it, and all of this is, as well, like you say, it's so high up that you've got less atmosphere, which is nice, but it means you've also got less oxygen to breathe, which means you tire out very quickly when trying to do manual work and lifting things. So yeah, it can be a tough climate for people, but it's a very nice climate for telescopes.
Yeah, and I think that's a really good example for showing just how big that telescope is in terms of compared to people. So I suppose the next question, Alan, is we see the size of it, but and you've already did a little bit of an explanation, but how do these vary from your common telescopes that we might use in the back garden or used here in the UK? How do these research telescopes differ?
Right. Shall I answer that one?
Yeah, that'd be great.
Yeah. Thanks, Alice. So thank you for that question. That's a great question. I think from Sam's amazing images there, you can see that the first perhaps big difference between something that you might have in your own back garden is simply the size of the telescope. And we make increasingly big telescopes primarily to capture more light. So the larger the mirror, the bigger the surface area, we're collecting more light so we can see those distant, very faint objects out there in space, like the nebulae and the images that we saw. And that's the primary purpose of building forever bigger and bigger telescopes. And if you want to look further into space and see more distant and fainter objects, there's two things that you can do. We can go up above the atmosphere, as Joe and Sam have described, and the ultimate of that, of course, is to pop your telescope up into space and have the Hubble telescope or the James Webb telescope, which is, I think, a 2.4 meter mirror, the Hubble, so about 4 times the diameter of our one, up there in space above all of the atmosphere, but perhaps even more remote in terms of servicing missions and so on. The other big difference between our telescopes and, in fact, all big observatory telescopes and the Hubble, between that and the kind of telescope you might have used at home, is that smaller telescopes frequently use lenses rather than mirrors. So you have a refracting telescope, and they're very good for looking at bright objects like the moon and planets and things. But as you make telescopes larger, it becomes less and less practical to use lenses to form an image. If you imagine a glass lens, it's thin at the edge and thicker in the middle, and it gets quite difficult to support that when you get to, something that's, a large fraction of a meter across. So all of our large observatory telescopes, the Pirate and Coast Telescope, the Hubble Space Telescope, all operate on the principle of mirrors rather than lenses. So we use a curved mirror to form the image. And the other primary difference between that and one that you might have looked through is that instead of an eyepiece where you would look through the telescope, we have sensitive cameras and detectors, or perhaps spectroscopy instruments to make scientific measurements that are attached to the back of the camera, to the telescope.
That's right. And I suppose, and that leads into another really good question we've just had come through is, are there any interesting research questions that can be approached with a good personal telescope? Is there anything that you can do research-wise at home?
There is so much you can do with a personal telescope at home. I mean, it's quite incredible just how many professional amateur collaborations there are out there. There's too many to name, but to sort of give some examples within my own field of asteroid science, a large proportion of what we call astrometric data, so measuring the positions of asteroids, is done by people with backyard telescopes. And that helps us to know what orbits these objects are on. So that's one way of contributing. There's ways you can contribute light curves that I showed before as well. And for when you've got a smaller telescope, it becomes harder to observe asteroids. So what you can do is you can even observe what's called occultations, where an asteroid passes in front of a star. And just by observing the dip in the brightness of the star, you can start to tell things about the size of the asteroid as well. And then there's projects like Exoclock, where you can help contribute timings of exoplanet transits for upcoming space missions like Ariel as well. So yeah, there is so much you can do with a backyard telescope. It's mind-boggling.
Yeah, astronomy is particularly open to amateurs getting involved, and I only use the term amateur because they're not paid for it. there's some so-called amateur astronomers out there that will give some professionals a run for their money, I think. But yeah, I mean, bear in mind that even today, there's a high proportion of things like comets and supernovae that are discovered by amateurs before professionals get their hands on them.
I suppose that leads into our actual OpenLearn course and how you can get involved with that. So this, I think, Alan and Joe, if you give a nice overview of, if you've done a nice overview of how you can get involved with it, if you should give some more detail about what this course actually does and what you can use and what you can actually see.
Sure, Alice. Yeah, absolutely. And everything that Sam and Joe have just been describing falls into the category of what we call citizen science, which is where, you know, anyone making their own observations on your own, either from home or you know, using a facility like COAST, you can contribute genuine scientific measurements and add to the pool of scientific knowledge. So there are all kinds of projects. Some are observing projects, which I'll tell you about now. And there's other ones that you can do, like Galaxy Zoo, where you know, you can help classify galaxies and, you know, look at images taken by professional observatories and help to categorize them. So images like this galaxy that I've got here on the left. But another great way to get involved with citizen science is through our OpenLearn Astronomy with an Online Telescope course. So what we've shown you so far are some of the great images of these celestial objects that you can take. So these are nice, beautiful images in their own right, sort of nature's artwork, if you like, cosmic artwork. And in the second 4 weeks of the course, you'll actually carry out some scientific measurements and contribute those to a citizen science type project. Now, Sam told you earlier about his work with asteroids, plotting the light curve of asteroids as they rotate. With COAST, you can take measurements of variable stars. So here we've got some more of the kinds of objects that you can image with COAST. And we've got the nebula down the bottom, the Dumbbell Nebula that we've seen. We've got another distant galaxy here. And then within our own galaxies, we've got these different types of clusters of stars. So these are regions where stars have recently been formed, or these globular clusters, which are ancient clusters of stars. And students on our mainstream undergraduate and postgraduate modules will make detailed scientific measurements of these star clusters and plot charts of the brightness and temperature and composition of these stars and be able to work out their distances, their ages, all those kind of things. Working with COAST on the OpenLearn module, you'll be able to make measurements of individual stars, of variable stars, and contribute those towards plotting an overall light curve, very much like the curves of asteroids that Sam showed you, but this time looking at stars which are varying for some reason. Now, sometimes stars vary because they're unstable, and sometimes they vary for other reasons. For instance, if you've got two stars that are orbiting one another, then sometimes one might pass in front of another, and you might have an eclipsing binary star. And the kind of measurements that you can make through the COAST telescope will allow you to plot, contribute your data together with data measured by other participants in the course, will all be plotted together to form an overall light curve for one of these interesting objects. So here we've got an eclipsing binary star, which is two stars orbiting around one another. And as they pass in front of each other, we get a small dip when one star passes in front, and then a larger dip when they pass in front of each other the other way round. So one star's brighter than the other. And as they pass in front of and behind each other, you get these dips in the light curve. So each of you measuring individually on one particular evening, you can see this is spread out over a number of days, might contribute one or two of these data points. But a large number of people, perhaps working from very different locations, even different places in the world, can contribute towards the same overall scientific measurement. So this is a great example of citizen science in action, plotting out these light curves, and you'll be able to do this, contribute your own measurements to this.
Brilliant, thank you. And this is a completely free course that anyone, if you don't want the link, you can sign up. And it's not just the telescope access, there's loads of other information there that you and Joe have created to work your way through, which is brilliant. And I think what's really interesting, if we looked at the polls, and I can share these results, you can see that most people want to see galaxies. That is the go-to response, is what you want to see. Sorry, my green screen is playing up behind me. They want to see galaxies. I always want to see planets. I think that's always my interest, is different planets. But that comes up very close behind.
Yeah, it's quite hard to see planets through these sorts of telescopes as well, because so often they're so bright they completely just blow out the images as well. So sometimes it's better to have smaller telescope than the larger research ones for things like that as well.
Yeah, that's a very good point, Sam. It's a really good example of where a kind of small telescope that you can use at home might be better suited for those kind of observations, looking at the moon, looking at planets, Saturn and Jupiter on the go at the moment, and you can see the rings and the moons. Remember, Galileo 400 years ago saw the moons of Jupiter through a very, very small telescope. So much smaller than anything you could have in your own back garden. So there are loads of things you can do. And it highlights as well, one of the things that we like as astronomers is that depending what you want to observe, we often need to have different telescopes for different purposes. So it's a great excuse for having more than one telescope.
Definitely.
Also, don't underestimate the power that astronomy can have over you when you are actually getting those views yourself. If you own a telescope at home, or even just a pair of binoculars, there's no reason to look down your nose at them in comparison to a professional telescope. As Alan's mentioned, Galileo was using a small telescope, and it obviously inspired him to go and find out more. And the same is happening for people even today. I mean, my interest in astronomy, developed as a young child through looking at Saturn through a very basic telescope that my parents bought me. So it's worth making that investment. Though, given what I know now, I'd say binoculars rather than small telescope. Wait until you can invest a wee bit of money in a telescope. But, just having that, first bit of contact by actually looking with your own eyes through these optical instruments adds a huge amount to your experience in the early stages of your interest, definitely.
Brilliant, thank you. Yeah, definitely. I think we've had a lot of questions about how to get involved and what telescopes to use. But I think some of the questions have been about how much telescopes should cost. But I think, I don't know if you want to give a brief overview or just say get involved with what you can.
Yeah, I mean, there are so many different ways of doing this. I think that I would definitely say go for a pair of binoculars first, because in the early stages of your interest, you're going to be trying to learn your way around the sky as well. So bear in mind that with a telescope, you've got such a small area of the sky that you're actually looking at. Getting lost can be quite easy. So a set of binoculars would actually put you in better stead with that one. When it comes to how much a telescope should cost, well, how long is a piece of string? We can talk billions if you want, but I'm guessing you're probably not going down that direction. I would certainly avoid any telescopes that you see for sale in supermarkets or something like this. They're often made of plastic and really not worth the investment. The best thing to do is actually to contact your local amateur astronomy group. There's an organisation called the Federation of Astronomical Societies that have a complete list on their website of all the amateur astronomy groups that are out there. And I'm really pleased to say that a lot of them are getting back now to doing face-to-face meetings and observing sessions. So try and get involved with them. Go to some of their observing sessions where there will undoubtedly be a large number of very, very passionate amateur astronomers with their own equipment that will welcome you with open arms if you want to have a look through their telescope and decide for yourself what works for you and what doesn't. It's a very personal choice. Quite a few societies will also have equipment that they can loan out as well, so you can borrow them for a short period of time and again figure out what works for you and what doesn't. So it's impossible to say you should get this and it should cost this much, but there are lots of ways of finding out for yourself.
Thanks, that's brilliant. I think there's always something to really keep in mind. We're going to take a completely different route now. Sam, is it true that an asteroid may hit Earth in 2029? I think I was going to say 2019, but we've passed that already. So 2029, is it true?
No, it's not. And this is a question I get asked a lot at talks, and so much so that I have a special slide just for it as well, because I feel sometimes we need to do a bit of shaming of the tabloids when it comes to these things. If you read in a tabloid that an asteroid is about to hit Earth, I can almost give you 100% guarantee that it's not true. You just have to look at these sort of the top right in the Express, 100% chance of impact, space expert alerts, right? That headline is so misleading, because let's say there's 100% chance of an asteroid hitting Earth, within the next few billion years. So unless you're planning on living for a few billion years, then I wouldn't really recommend worrying about it too much. Now, obviously, there are asteroids that do come close. So the one I think you refer to is Apophis, which was thought to be a potential impactor back in the early 2000s. It was predicted that it could impact in 2029. But as I mentioned before, you can do these observations. Amateur and backyard astronomers helped contribute these observations, refining the position of the asteroid. And the more and more of these we got, the better we knew its orbit. And that meant we were able to completely rule out the chance of it impacting. And this date that it has on here, 2068 as well, it's something like a one in a billion chance that it might hit what's called a keyhole and end up impacting Earth in 2068. But it's so unlikely. You're more likely to need to worry about crossing the road than anything like this usually. But us in the field do monitor these asteroids to keep an eye and make sure they're on. And we run simulation exercises on what we would do and how we would react if there was one coming towards us.
Is that why you got interested, or was there a specific reason you chose the asteroid route through astronomy?
To be honest, if I'm perfectly honest, it was complete luck. or completely random, I should say, in that I was meant to choose a project for my master's degree to do when I was at Kent, and an administrative error meant that I wasn't assigned a project until the last minute, and there was a lecturer I knew well who agreed to take me onto his project, who studies asteroids and comets. And from there, I mean, as soon as I started, I just knew, I want to do this as a career. I was always interested in space, but that really refined it down to sort of solar system science.
And it's such a big field as well. Even within the solar system, it's a massive field.
Yeah.
Brilliant. I think I've got another question for you, Sam, is how can you tell what an asteroid looks like? Is it just through imaging, or is it, and you've talked about the light curve as well?
Yeah, so there's kind of two ways you can do it that are complementary. So from looking at the light curves, so how the rotation changes the brightness, you can start to tell about how elongated it must be at that viewing geometry. And if you observe it from lots of different locations, so from like the bottom, top, side on, etc., you can combine all of those and you can begin to get an estimate of of what the shape must be. So I have an example. So this here is, I'll move it in front of my face so you can see it. This is an example of an asteroid that we observed with Pirate recently. Obviously, this isn't the real thing, but so we took light curves like you saw before over loads of different geometries over many months, and eventually we were able to feed all those into a computer program which estimated what the shape must look like in order to produce those light curves. And I suppose the other way would be, so you've got what's called radar, where you can essentially send out strong signals of radio waves towards an asteroid and observe how they're reflected back. So we used to use the Arecibo radio telescope before it collapsed. May it rest in peace. And also the Goldstone dishes, which NASA uses to communicate with spacecraft. We can also use to tell the shapes of asteroids using those as well.
Brilliant, thank you. I'm just going to do a quick reminder. You've possibly got about 10 minutes left to get any questions in. So if you've got any questions you want to ask before the end of this session, drop them in the Q&A box and we'll hopefully get them asked to our panelists. I think I've got one for Alan and Joe here about what we offer. So obviously we've got the post ones. We've got a question here about, do we offer any radio telescope facilities and anything that we can use at the OU for radio imaging?
Yes, thanks, Alice, and thank you whoever asked that question. Yes, I can certainly tell a little bit about opportunities that we have for working with radio telescopes. And Sam mentioned briefly there looking at asteroids using radar. And so everything that we've described to you so far with the Coast and Pirate telescopes has been using light, taking images in visible light with what we call optical telescopes, reflecting telescopes and so on, taking images. But as astronomers, we want to get as much information from the universe as we can, and we can use different parts of the electromagnetic spectrum. So we could use infrared light, which is good for looking through dust and things in the galaxy. And we can also use radio waves, which allow us to see phenomena that we can't see using the naked eye. And we do have on our mainstream undergraduate courses, the remote experiments in physics and space that I look after, we have two parallel projects looking at the structure of the galaxy. The first of those is the Pirate and Coast optical telescopes that we talked about. And the second of those is this radio telescope, which is actually based at Milton Keynes. So this is the Arrow radio telescope. And so we split into kind of two parallel streams, both looking at the structure and layout of the galaxy, one using the optical telescope measurements of those star clusters that I showed you earlier, and the other part of the project is using the radio telescope dish. Now, this is a 3-meter dish. So radio waves are longer wavelengths than optical visible light. They're all part of the electromagnetic spectrum, but we use a much larger dish to collect the radio waves. And this isn't like the kind of radio where, you know, you'd listen to your favorite music station or something. The signals that we get here aren't in the form of sounds, but they're in the form of spectra. And the specific frequency that we're looking at is radio waves that are emitted by clouds of hydrogen gas in the galaxy. So our galaxy that we saw in that previous image is a big swirling spiral of gas and dust. So we have the spiral arms, and looking sideways, we've got the disk and the bulge, and then these clusters in the halo and in the spiral arms. And these arms are made of clouds of hydrogen gas, which is where stars are being formed as that gas compresses down. And so by looking at the radio waves that come from those clouds of hydrogen gas using the radio telescope, we can actually plot out, we can use the Doppler shift to measure the speed, how quickly they're coming towards or away from us, and actually map out the structure of the galaxy. So that's a good way where the different parts of the electromagnetic spectra allow us to hook into different types of phenomena, in this case, the emissions of radio waves from our hydrogen gas, and to explore the universe in different ways. Now, using this telescope and the Pirate and Coast telescopes is part of our undergraduate curriculum, which you can, if you're interested in doing that, you can do either a complete degree or you can do an S20 certificate in physics, which will physics and astronomy, which will involve doing this course with remote experiments, which would involve chance to use the radio telescope. At some point in the future, I think Joe and I would very, very much like to write a counterpart to astronomy with an online telescope, which would be astronomy with an online radio telescope. And we'll bring you more news of that as and when we get to do it.
Definitely watch this space.
Absolutely.
We've got some last minute questions. I'm going to sort of, and we've got a few minutes left, I'm sort of fire them at you. Joe, what level of scientific knowledge is needed to do the online course, would you say?
You can be an absolute beginner. We don't assume any prior knowledge at all. So we will take you from the absolute basics and up. So go for it.
Brilliant. I think we've got some students that are going to be doing it in year 9. So we know at that level they're able to, even with the pre-GCSE as well, would you say?
Oh, yes, definitely. I would say perhaps more appropriate for secondary than primary. Though that said, I'm based in a primary and I've used bits of the course with students. But yes, I would say secondary school and up. There's quite a lot of focus within the course on aspects of the GCSE astronomy course. So if you are undertaking that at the moment, either as a student or a teacher, then hopefully you'll find many aspects of the course that will be of use to you.
Brilliant, thank you, Joe. Sam, I don't know if you know this, but very quick question. How big is the largest asteroid that we know of?
So I'd say probably going on, I think it's around 300 kilometers.
So very big.
Probably bigger than that, I'd say. Yeah.
And when do you think an asteroid will hit Earth? This is from some year 9 students in Bedford.
So they actually can hit. They hit fairly often, but they just tend to be so small that they just burn up in the atmosphere. And that's what we see as sort of meteorites and shooting stars in the night sky.
Brilliant. Yeah, I mean, I think there's that one in Russia a few years ago was another one as well, wasn't that? Hit in the forest and got absolutely flattened as well. I can't remember whereabouts that was.
Yeah, there was I think it was 2014.
Yeah.
Chelyabinsk. Yeah.
I've got another question, which I think that they're sort of linked in together. So from the year 9 students is, does anyone think there is life elsewhere in the universe? And it's sort of linked into this is, any thoughts on the SETI discussion? Does anyone want to give a brief 2-minute?
Shall I answer this one, or Joe, would you?
Go on, Alan.
Well, it's one of the questions that Joe and I particularly probably get asked quite a lot
I love getting this question.
Amateur Astronomical Society. Well, I'll give my answer, and then Joe, you can add to it. We're often asked this. We're up at the telescope, and we're asked, when we look out at the night sky, that galaxy that I showed you as our nearest neighbor, that Andromeda spiral galaxy, that beautiful spiral. And that's just one, when we look in the Hubble Space Telescope pictures of billions and billions of other galaxies. And one of the exciting things that we've learned over the last 15, 20 years or so is that when we look at those stars in our own galaxy, that a large number of them do have planets going around them. So, if you'd asked me 50 years ago, we would just say, well, we didn't know whether it was a rare thing for a star to have planets and we were a kind of unusual thing to have a solar system, or whether it was fairly common. And we now know that it's extremely common. The vast majority of stars do have other planets going around them. And when you think that's just in our own galaxy, and you see all those billions of other galaxies, we don't know for sure, of course, but it would be absolutely astonishing if none of those other planets had any life on them. It would be absolutely astonishing. Now, in our own solar system, we've got Mars rovers and so on looking for evidence of previous life on Mars, and we'll learn a lot more about that if you come to our undergraduate course. But that's my answer. I don't know. Anyone got any other thoughts on that?
I'll say I love getting this question, particularly when it's asked by predominantly young school children, because the question that they think they're asking is, little green men, alien abduction, that side of things. So when I answer yes to do I think there are aliens, they all look slightly shocked at me. But of course, the question that I'm actually answering is the one that Alan has alluded to. That no, I don't believe in alien abduction and that side of things, but it would be the most spectacular waste of space in every sense of the word if there wasn't something else out there. We will probably never meet them, make contact with them, even discover that they exist. But there's bound to be something out there.
Sam, any thoughts?
Yeah, I can only echo what Joe and Alan have said, to be honest. It seems so unlikely for there not to be anything. It would hurt my mind to imagine a universe without anything else.
Mm-hmm. Yeah, and I suppose we'll hear in the next few years whether anything's as we search or within the solar system, as we go past Ganymede and some of the moons of Jupiter that may hold a chance of something. So we'll keep an eye out and see what comes up. I think we're coming to a close, so I'm going to finish off on a question. Having used these telescopes, Sam, I may know your answer already considering your research, but is there anything that's your favorite thing to object to image? Is there anything that you've imaged an image that you found particularly amazing that you've taken with these telescopes? It's to be a hard question, but is there one favorite image that you've taken that you would love to share or describe?
Yeah, I mean, I'll quickly just share mine really quickly. So my favorite thing to image actually isn't asteroids, because asteroids can be quite, it's just a point of light, one point of light in an image. But this is probably my favorite image I've taken, which is one I took with Pirate recently, of the Pillars of Creation. Here is quite a famous Hubble image focused on this area here. And I mean, I love taking images of nebulae. It's by far my favorite thing to image in the night sky.
That is a beautiful one. Alan, Joe, any favorite things you've enjoyed imaging?
I think anything that we see through the Pirate telescope or the Coast telescope is absolutely amazing. I showed a sort of couple of pictures. I'm just going to show you a larger picture there of our nearest neighbor, the Andromeda galaxy. As we look into space, we see these more distant galaxies, but to see this kind of nearest neighbor with these swirling clouds of gas and dust, we can't take an image of our own Milky Way galaxy because we're kind of inside it. But to be able to look at a kind of nearest neighbor spiral galaxy that is similar in makeup to our own, gives us some idea of what our own home galaxy is like. And to think that, we've got all these billions of stars and swirling clouds of gas and new stars forming and old stars dying all the time, just gives us a real sort of perspective of, where we are in the universe. So honestly, any time I get an image back from the telescope, I'm absolutely amazed and thrilled. So it's just an exciting thing. And if people are getting involved, I would say, to come back to the earlier question, enthusiasm and interest, wanting to find out more will take you, a lot further than sort of prior academic knowledge, if you like.
And yeah, I think there's going to be a lot more information coming out. Before we go, Sam, you mentioned the OU asteroid. Do you want to give literally like a minute explanation about the OU, and Joe?
Yeah, I can do that. It was hoped that this would celebrate the Open University's 50th anniversary in 2019. But so a couple of years ago, we put in an application to the International Astronomical Union to have an asteroid renamed in honor of the Open University. And the number was chosen to represent the date of the formation of the Open University on the 23rd of April, 1969. And that was announced just a couple of months ago.
I think you showed Monitor Drady has an asteroid, who's one of our colleagues at the OU. I think she's got an asteroid named after her as well.
Yeah, you can name it after people as well. There's only one person who ever got away with naming it after his cat. And that's because his cat shared a name with Mr. Spock from Star Trek. So
brilliant. Absolutely brilliant. I'm just checking if we got any quick questions. I think the very final question I'm just going to fit in. I think this is Joe, Joe or Alan or Sam can either answer this. We've talked a lot about imaging these and looking at these objects. How do people find out how to locate the different star clusters, nebulas and planets to look at them through a telescope? Is there any app that they can use to sort of look at these in the sky?
Yeah, absolutely. And indeed, we introduce you to the free software that you can use that's both on your computer and on a mobile device, all as part of the course. So if you want to learn how to do that, then go join the course and it will answer all those questions for you, guide you through how to do it.
Brilliant, thank you. And I think, I'm sad to say, that is all the questions we have time for today. Hopefully you'll agree that this has been a really interesting and informative session, and you'll be able to go out and find out a load more information and hopefully join these tasks as you go through. There is more information available, so if you're interested and you do the course and you still want to learn more, we have our physics certificate, so certificate of physics, which is a level 1 course, and that should also be popping up in the chat now. And that's the OpenLearn course is free, but this is one of our paid modules. And then obviously there is our degree that you can join and get more experience on as well, so that all that information will be available in the chat if you're interested. And all that is left is for me to thank my amazing team of panelists, and we hope to see you at our next event. So thanks very much.